All right. Hello, everyone. Today we're going to go over the lifespan of a star. So we talked about the structure of a star, but now we're going to talk about its different lifespan. And there's actually three different ways a star can live its life, to sort of say. We'll go over those today. So we will explain and describe the life cycles of a star. All right. So before that, we can predict the temperature of a star based on its color. This will be important when we talk about the different life cycles of a star because they usually end up with different colors. So the color of a star predicts its temperature, and here are their colors and temperature. Blue stars are usually around 25,000 Kelvin, white stars are 10,000, yellow stars 6,000, orange stars 4,000, and red stars 3,000. And this is just based on the surface temperature, not the inside temperature. So our star is a yellow star. It's around 5,000, around over 5,000 Kelvin, so it's around 6,000. So here are the different stars. An example, we have a blue star here, a white star here, a yellow star, which is our sun, an orange star, and this is a red star. And this is actually called Betelgeuse. I think we watched a video on this earlier in the semester, and yeah, this is the Betelgeuse star. Also, there's usually different sizes of star. You can see on the picture to the right, this little dot you see here is our sun, and this is another star called the Canis Majoris. And generally, a common relationship between mass and age is that the more massive a star is, the shorter lifespan it has. So our star can actually live a lot longer than this big star. This is usually because, as you can tell inside, this has a large core, so it undergoes a lot of nuclear fusion, and it needs more heat and energy to account for their large gravity, or the core will collapse. And we'll talk about the collapsing the cores a lot more when we talk about the life cycles very soon. All right, so this is the beginning for all stars. So all stars start this way. They start in the form of a nebula, which you can see on the picture here. This is just a combination of dust and gas in space. Space is not completely empty. There's also dust and gas throughout. So usually the dust contains like silicon and carbon, and then the gas is hydrogen and helium. It becomes like a little cloud-like area you can see here. And over time, these particles will eventually come together. And then as they come together, there'll be more gravity coming into one form and create a protostar. So here's a protostar. You can see the shining light. Protostars happens when I mentioned before, when the particles in the nebula just clump together to form a small core. So this core gains enough gravity that it produces heat, and then once it has enough heat, there'll be nuclear fusion between hydrogen to create helium. And as I mentioned before, a nuclear fusion between hydrogen causes the sun to arise. That's what the sun has. So usually the protostar wants to collapse because of its gravity, because it's keep on getting bigger and bigger. But usually the gas pushes the force outward, and it forms a star to prevent the collapse. So now this is where the first part of the life cycle will be split. This will be dependent on their size. So as I mentioned before, all stars start as a nebula and protostars, but then now they'll be different between a small medium star and a large star. And then the largest stars will also have a small split of how they end up later. We'll go over that. So we're going to start with small medium stars. These are stars similar to the size of our sun or smaller. They can live for billions of years, and the pattern is they'll become red giants, a planetary nebula, then a white dwarf star, and then also a black dwarf star theoretically, which I'll go over. Example of small medium star is just our normal sun. It's a medium-sized star. All right. After some time, the star will become a red giant. So the medium-sized star will ran out of hydrogen. So now they'll use helium for nuclear fusion, and that helium will fuse into carbon and oxygen. And since carbon and oxygen are a lot more massive than helium, this causes the sun to expand, or the star to expand outward. Expansion can be 1,000 times larger than the current size of our sun. So by the time our sun becomes a red giant, it would also consume up till Mars. So Mercury, Venus, Earth, and Mars will all eventually just be consumed by the red giant sun. That's a good image to think about. All right. Once the sun begins to run out of elements, so the carbon just stops fusing, it becomes another nebula. The red giant basically expands so much that it dissipates elements to create another nebula. And it only leaves with the core of the sun. And this nebula, of course, also has a lot of silicon, carbon, and then helium. The difference between this nebula and the other nebula is this is a planetary nebula, and it's more of a ring shape, if you can notice here. The other nebula is more of a cloud shape, so that's the big difference between the two. Finally, after a small medium star will become a white dwarf star. This is just the core left over from the star, and it has a lot more density, so there's a lot more mass, even though it's smaller, but there's no nuclear fusion going on. So also because there's a lot more mass, there's a big amount of gravity, and it still has a lot of heat as a white dwarf star. As you remember, white stars are one of the second highest heat, so this is why they're very hot. Now this hasn't happened yet to any star in the universe yet, because our universe hasn't been around for quadrillion years, which I'll go over. They're originally a white dwarf star, but theoretically, they can turn into a black dwarf star once they ran out of energy. So once their heat dissipates, they become a black core. This is theoretical, it has not happened yet, as because it would theoretically take around a quadrillion years, and our universe has only been around for billions of years. All right, so now we're talking about large stars. These are like around 3 times larger than our sun or more, and they have shorter lifespans. And then all large stars become red supergiants in a supernova. But after the supernova, depending on how large it is, it'll either become a neutron star or a black holes. So let's go over that. So red supergiants, they're actually basically very similar to red giants for small medium stars. The hydrogen becomes fused to helium, and then the hydrogen starts to run out. So the helium again fuses to carbon or oxygen, which expands the sun. But unlike the red giants, the supergiants fuse more. The carbon and oxygen fuse into even more heavier elements until they finally fuse into iron, which expands it even more. And as you know, iron has a larger mass than carbon and a lot of other elements, so that's why this instead of it becoming a red giant, it becomes a supergiant. Now, because the star becomes so big, eventually the core will collapse and it'll cause an explosion called a supernova. These explosions happen so fast, and the speed of which the explosion occurs can be around 23% the speed of light. So around a fourth the speed of light, it's still very fast. And the temperatures can even reach up to 100 billion Kelvin. Oh, I forgot an L there. Typo. Anyway, after the supernova basically disperses all those elements at a rapid speed and also would likely destroy anything in its path. This leads into neutron stars or black holes. So neutron stars happens to stars that are at most 3 times larger than our sun. It can be a little bit smaller, but still larger than our sun. So after the supernova, the iron protons and electrons start to fuse together to make pure neutrons, and that makes just the core of neutrons occur after the supernova. This is the smallest type of star, but it is the most dense. So this can be smaller than a white dwarf star. So even though it has such a small space, it has so much mass, so it has a strong amount of gravity. And also because of this, it can also emit X-rays based on its light. Now, it's not big enough to collapse about itself. That's what's going to happen for a black hole. So as you can imagine, stars larger than 3 times the mass of our sun would have a core that is even more massive than a neutron star. Now, because it collapses so much and the core is so big and massive, and there'll be so much gravity that it causes a singularity or a black hole. This black hole has a large amount of gravity and can pull anything, including light. And the reason why it appears as a black hole is that there's a lack of light, so there's nothing you can see. It's just a pure darkness. Now, there's a lot of science fiction stuff, a black hole about, oh, alternate universe or something like that. That's not really possible because the gravity that black hole emits would honestly destroy anything that comes near it. The process is called spaghettification. Alright, I'll show you a black hole from Mario Galaxy. Let me pause the music here for this. I just thought this would be a fun little thing to see for instead. Aim at the volume up. If you can't hear it, let me just click on the video itself. Sorry about the low volume. See, the sun is expanding or star expanding, and then it explodes upon itself, and there's a black hole. So there's the black hole after the sun expands. Like I said, everything is sucked into a black hole, even in video games. Alright, that was a fun little thing I just wanted to show. Just a black hole from a video game instead of a simulation. Alright, anyway, this is the... Sorry, let me try it. I'll leave it like this. This is the summary of the life cycle of a star. As you can see, there's 3 paths. Every star starts as a nebula and a protostar. Then when it's a sun, same size as the sun or smaller, it becomes a red giant, planetary nebula, white dwarf, then theoretically black dwarf. If it's a massive star, it becomes a red supergiant, then there's a supernova occurs, and then depending on how massive, it can be a neutron star or a black hole. The assignment I give you will have you explain each part of the life cycle of the star, and you can't just say the names, you have to explain each part and what happens in each. All right, so the mastery assignment will involve both the life cycle of the star and the structure of a star, and will be provided to you with a Google Doc to work on. All right, that's the end of this lesson. Thank you for watching, and sorry about that volume for the video. All right, bye.